Hey, what's up, my Padawan learners? Jedi Master Boylan in the house. What in the heck are we gonna do in this vid? We're gonna use the Force, the law of conservation of mass, to write chemical equations. Breaking it down as always, we are going to 1. Balance a chemical equation, and 2. Relate the importance of balancing a chemical equation to the law of conservation of mass. Alright, so first, what the heck is a balanced chemical equation? It is just a chemical equation that follows the law of conservation of mass, which, as we all remember, states that mass is neither created nor destroyed during a chemical reaction. It's the law! Follow it! So, let's take a look at this thrilling animation from the awesome folks at FET to help us better understand what that means. On your screen, we've got an equation that represents the decomposition of water into its elements, hydrogen and oxygen. If I had one molecule of water forming one molecule of hydrogen and one molecule of oxygen, notice that we're not following the law of conservation of mass. Notice that we have somehow magically created an extra atom of oxygen on the product side. So, writing a balanced chemical equation in order to follow the law of conservation of mass is going to ask you to think about what ratio your reactants and products must be in so that you don't create any mass and you don't destroy any mass. Yes! Okay, so how are we going to do that? First of all, it's important to know that if you're provided a word equation, that you translate it to one of those formula equations that we talked about in an earlier vid. Makes it a heck of a lot easier to balance. And then it's really just a matter of trial and error. You're going to add coefficients to your reactants, you're going to add coefficients to your products until you satisfy the law of conservation of mass, until your equation illustrates that you haven't created and you haven't destroyed any mass. It just takes practice. However, fear not. There are 4 Jedi tricks to help make the process easier. First Jedi trick: balance only one type of atom at a time. Don't try to balance the whole thing at once. Know some of you think you're Jedi Masters already, but that's how you go to the dark side. Take your time. One type of atom at a time. 2. Balance the atoms of elements that appear only once on each side of the equation first. It's Jedi trick number 2. Jedi trick numero 3. Balance those polyatomic ions that appear on both sides of the equation as single units. Take a look at and practice this Jedi trick in some of the guided practice videos to follow. And then finally, Jedi trick number 4. Balance hydrogen and oxygen atoms after all the other types. Generally, that's because your hydrogen and oxygen will appear in multiple places throughout the equation. Alright, now let's apply those Jedi tricks to this example, the combustion of methane. If we initially start with one molecule of each of our reactants and products, do we have a balanced chemical equation? Answer: no. As it sits currently, we've magically destroyed some hydrogen and magically created some oxygen. Now again, it's just trial and error, changing your coefficients until you get your equation to balance. But let's use some of those Jedi tricks to help us out. I'm going to save oxygen and hydrogen for last. So I'm going to focus first on my carbon. Notice that I currently have one atom of carbon on the reactant side and one atom of carbon on the product side. So my carbons are already balanced. I'm not going to change these coefficients at all. Now, as I try to decide, but should I balance hydrogen or should I balance oxygen next? Notice that hydrogen appears only once on the reactant side and once on the product side. Oxygen appears once on the reactant side, twice on the product side. So it's generally a good idea to balance those elements, in this case hydrogen, that appear only once on either side of the equation first. Notice that I have 4 atoms of hydrogen on the reactant side, 2 atoms on the product side. I look at where my hydrogen is located on the product side, in this case water, and I change the coefficient until my number of hydrogens match the number of hydrogens on the reactant side. Which brings us finally to oxygen. Notice I've got oxygen in 2 places. Easy to make a mistake with the oxygen. I've got 4 total atoms of oxygen on the product side, only 2 on the reactant side. So now I'm going to adjust the coefficient for oxygen on my reactant side until I balance my chemical equation. Jedi Master. And then lastly, once you've added your coefficients to the point where you think you've balanced your chemical equation, just count all your atoms up the end to make sure your equation is balanced. And make sure those coefficients represent the smallest whole number ratio of reactants and products. Sometimes when we're balancing, we're able to get it to balance, but it isn't the smallest whole number ratio. So if you end up in a situation like that, just divide by the greatest common factor to get at the smallest whole number ratio. All right, lastly, I just want to hit on some common errors that students make when they're balancing chemical equations that you need to avoid. Your nomenclature is never going away. So many times if you can't get an equation to balance, it's probably because you wrote the incorrect formula. Nomenclature. Don't let the dark side take you over. Always make sure your formulas are correct before you try and balance. Don't forget those diatomics. Trouble? They are. Second common error. Students try to balance the equation by changing the subscripts. Sounds like an easy fix to balancing. Don't fall for it. The dark side is tempting. Notice that it does bring balance to the chemical equation. However, when you do that, you're no longer depicting the chemical change that you were originally describing. H2O2 hydrogen peroxide isn't water. Third common error. Students incorrectly calculate the number of atoms for those elements that are inside of a parentheses. Be careful. Take a look at the example on your screen. Magnesium chlorate. If I had a coefficient of 1 in front of this compound, it would mean I have 1 magnesium, 2 chlorines, and 6 oxygen. And when you're balancing and adding coefficients, for example, if I put a coefficient of 2 in front of this compound, it would indicate 2 atoms of magnesium, 4 atoms of chlorine, and 12 atoms of oxygen. Whew, tricky. The dark side, always trying to drag us down with their trickery. Parentheses. Parentheses are kind of like the Death Star. Then final common error, students like to put a coefficient in between instead of in front of a chemical formula. That's a Vader move. Don't do it. H220 isn't a thing. Sure, my oxygens are balanced. Boom, my hydrogens are balanced. But H220 does not represent water. Don't do it. All right, and that brings us to the end for this vid. Remember, always use the Force. The Force. For good. Stay away from the dark side.